Welcome back to The Explainer. Today we're getting into the invisible architecture that runs practically everything behind the scenes. We're talking about relational databases. But more specifically, we're going to look at exactly how these databases connect information. It's a completely foundational concept, but honestly, getting it wrong can absolutely crash your entire system. So let's just dive right in and master Oracle SQL joins, starting with a scenario I think we can all relate to.
Imagine sitting down at a really nice restaurant. You order a steak, right? But suddenly, the waiter brings you not just the mashed potatoes you asked for, but also the asparagus, the fries, a side salad, and a bowl of soup. Imagine the sheer chaos on your table. Not to mention the massive bill at the end of the night, all because you paid for 6 side dishes when you literally only wanted 1. Well, this is exactly what happens inside your database when you ask it to match tables together without giving it strict rules.
To keep our data accurate, here is our quick roadmap for today. 1. The Cartesian oops moment. 2. Precision with inner joins. 3. The left join safety net. And 4. A quick join comparison summary.
Okay, section 1, the Cartesian oops moment, understanding the Cartesian product. Let's see what actually happens when a join condition is completely omitted.
There's a stark difference in syntax here depending on how you write it. You've got the old-school implicit format, which is basically just a comma between the mains and sides tables, and then you've got the modern ANSI explicit format, which we know as the cross-join. But here's the thing. Regardless of which syntax you use, if you don't provide a filtering rule, Oracle's database engine does the only thing it knows how to do. It matches every single row of table A with every single row of table B.
Let's apply this logic back to our restaurant menu, just to see the real-world impact. In our database, we have 2 tables. Our mains table has 2 items, a grilled salmon and a ribeye steak. Our sides table has 3 items, mashed potatoes, roasted asparagus, and truffle fries. Now if we run a query using a Cartesian product, every single main dish is automatically paired with every single side dish, completely regardless of whether it actually makes culinary sense.
This brilliantly illustrates the multiplication effect. Our 2 mains multiplied by our 3 sides generates 6 total combinations. The database pairs the salmon with the mash, the asparagus, and the fries. Then it turns around and does the exact same thing for the ribeye. Now, 6 rows doesn't sound too bad, right? But imagine a real corporate database with, say, 10,000 customers and 5,000 products. That missing rule, it just generated 50 million rows. That is a massive performance hit that will literally bring your servers to a grinding halt.
To prevent that kind of disaster, let's move to section 2, precision with inner joins, the power of the inner join. Let's build an intentional pairing strategy. By using an inner join, we move from total chaos to exactly 100% accuracy. Why? Because instead of just blindly multiplying tables together, Oracle uses indexes to find distinct, designated matches instantly. You are completely avoiding that full cross-product performance hit we just talked about because you're telling the database exactly what belongs together.
The absolutely crucial point here is the specific syntax. It's the on clause. On m.id equals s.main_id. Think of this as your bouncer at the door. The on clause filters that massive Cartesian product down to only the rows where the ID of the main dish perfectly matches the main_ID listed on the side dish. If the IDs don't match, the row is rejected and thrown right out.
When the logic works perfectly, our grilled salmon, which has an ID of 1, links strictly to the roasted asparagus, and our ribeye steak with an ID of 2 links strictly to the garlic mashed potatoes. The noise of all those impossible combinations is entirely gone, and we are left with just 2 highly accurate, correct rows. That, right there, is the power of the inner join.
But hey, data in the real world isn't always perfectly paired. So on to section 3, the left join safety net, mastering the left outer join. Let's look at a super common edge case. What happens when we have a primary record that simply doesn't have a match assigned to it yet?
This is exactly where the left outer join acts as a vital safety net. The mechanics work like this. First, it preserves the primary table, meaning it keeps every single record from the left table in your query, no matter what. Second, it fills in the blanks. If there's no matching record on the right side, Oracle just fills those columns with a null value. And third, this makes it an incredibly powerful tool for data auditing, allowing you to easily spot orphaned records that are just missing information.
Let's look at a prime example of an orphaned record. Let's call it the lone cauliflower. Imagine we update our restaurant menu by adding a brand new vegan cauliflower steak to our mains.
But the chef hasn't decided on a side dish yet, so it has absolutely no matching record in the sides table. If we used our previous tool, the inner join, it would look for a perfect match, fail to find one, and completely hide the cauliflower steak from our inventory report.
And obviously, we can't have missing inventory. So by utilizing a left join instead, we ensure a complete inventory audit. Because the cauliflower steak is on the left side of our query, the database keeps it visible. It displays the main dish perfectly and simply notes that the right side, the side dish, is null or empty. You get the whole picture without losing your unmatched data.
All right, we've covered a lot of ground today. Let's pull this all together in Section 4. Join comparison summary, recap of rules.
Recapping our journey, we started with the Cartesian join. The row count logic there is m times n, showing all possible permutations. Its risk level is extremely high, critical really, because it can totally overwhelm a system. Then we transitioned to the inner join, which only shows perfect matches and aggressively excludes mismatches. That's a low-risk, safe choice for precise data. Finally, we explored the left outer join, which safely keeps all your primary data from the left, adding nulls where the right side falls short.
Connecting the abstract SQL logic directly back to our restaurant plates really reveals the full picture. You have the omitted join generating every single crazy combo. Then you have the inner join insisting on identical IDs for the salmon and ribeye. And then you have our left join safety net keeping that cauliflower steak perfectly visible. If you think about these as Venn diagrams, the Cartesian takes everything in both circles, the inner takes only that overlapping center, and the left takes the entire first circle plus the overlap. By understanding these three distinct mechanics, you now have the foundational tools to confidently pair precise data while actively preventing missing inventory in your systems. You know exactly how to stop the multiplication effect, how to enforce rules, and how to audit your tables.
But as we wrap up this explainer, I want to leave you with a little thought to puzzle over. You've mastered preserving the primary table with the left join, but what happens when you need to flip the logic? What if you need to preserve everything from the secondary table on the right? Keep exploring these database relationships, because once you realize you can look at the data from the completely opposite direction, a whole new world of data auditing opens up. Thanks for joining me, and happy querying!